bring your voice down because I'm recording this live. Okay? So, last 10 minutes I have here, we're going to talk really quickly about something called similar polygons. Squares and rectangles is going to be your first assignment for this week. So on the top of your graph paper, you want to write down similar polygons, squares, and rectangles. Do that now.
Are you recording this?
Oh, that's not what I want. Now I can't even erase it. There we go. Ah! There we go. Perfect. I would like a square.
Are we writing this on the...
Graph paper. Oh, look at that. Sometimes I amaze myself.
Okay then.
Don't you amaze yourself sometimes? You figure something out?
Yeah?
Are these two squares similar?
Yeah.
Why are they similar?
They're squares.
They're both straight up and
Put your hand up in
Not
here.
degree.
Okay, go ahead.
They both have 4 sides.
Okay, so they both have the same number of sides. Why else?
90 degree points.
Hands.
They're both squares.
They're both squares, okay?
They both have 90 degrees.
They both have 90-degree angles in them. Okay, yeah.
Oh, that's
Okay, yeah.
They both have straight lines.
Okay, so they have the same. Anyone know how to draw the sign for an angle? Yeah?
Dot.
Okay, this is what I just saw.
Protractor.
No, I didn't do that.
That's exactly what I saw.
Isn't it a protractor?
Not quite. What? How do I write an angle? Do it again.
This. Well, it really depends.
Okay, go. I have no idea what you're doing. Go.
A dot.
A dot. Oh, that's degrees.
Yeah.
Okay, that's one way to do it. How else can I write it?
A and G.
Okay, I can write it out. Have you ever seen this sign?
Oh, yeah.
That's a angle.
That also means angle. Okay, or you can use this, the degree. So they have the same angle. You're going to want to write this down. Okay. They also have the same ratio of sides. Okay, so what that means? Oh, perfect. It was just look at here. Okay. So if this is 1 and this is 1, right? If my sides are the same length, if this is 3, what is this one going to be?
3.
It's going to be 3. So the ratio of the sides is the same. I'm just going to close this.
Why does it say same and then same ratio of sides? Can't we just write 1?
Write it however you want. It's your notes. Okay? Now on this, you want to keep this fairly small. I'm writing big. You'll be able to use the back of your graph paper too. If I have a rectangle, it changes a little bit. So here, oh, I don't want a square. I want a rectangle.
Can't you just like push it over?
Not on that one. So if I have a rectangle now, are these similar?
Yes.
Yeah, we don't know exact because I don't have the measurements on it. But if this is 1 centimeter wide and 4 centimeters long,
It's the same one. 2 and 8.
and this, yeah, this is 2, this one has to be 8. What does this remind you of?
2 circles.
Not the 8, similarities. It was in one of the questions in Jeopardy.
They're double the size, but they're and they're double the what you call it.
Okay, what if I did this? If I write 1 over 4 as the relationship between width to side, this is 2 over 8. What would another equivalent or similar rectangle be?
It would be 3 over 12.
3 over, as I knock it over, 3 over 12. These are equivalent ratios. If I multiply the top one by 3, I multiply the bottom one by 3. Okay? So let me go to another page, I'll show you that.
Do we have to write down all the shapes?
So if I have 1 over 4, and I times this by 2, and this by 2, I'm going to get 2 over 8. Right? if I have 1 over 4, and I multiply this by 3 and this by 3, I'm going to get 3 over 12. Equivalent ratios. Guys, the things you do in math are never isolated. Are you okay?
Did we watch this video or did you post this video?
This is, yeah, I'll post it on the D2L. So the big thing with this, guys, is that this is part of our fractions unit. But when we get into geometry, really important. Okay? You guys good with this? Can I move on?
Yeah.
Oh, wrong way. So, here's your challenge. I want you to draw the largest square that you possibly can on your graph paper.
Which side?
Either side, doesn't matter.
Make it huge. Okay.
What's that? Yeah, but remember it's a square, so all sides have to be equal.
Oh.
It can't be a rectangle. I want you to make a square.
So we have to count. 1, 2, 7, 30. Only one?
Okay, but guys, I'll take a snapshot of this and I'll paste it for you so you don't have to write it down. Okay? So you should have a big square. Using squares and rectangles that are similar, fill the entire page. For a challenge, add similar right triangles. So what this means is here's my square. You have to use every single square on the graph paper within your square. You can't leave anything out. Okay? So for example, my first one is going to be a square. A similar square will look like this. What I'm going to do is I'm going to label each one of those with a 1. You can have up to 4 different similar squares. Now let's say I'm going to add a rectangle. That's like this. This one I'm going to call number 2. I have to have another similar sized rectangle. So if this is 1 by 6, this one's going to be 2 by 12.
You can use up every square.
Yes, you totally can.
Look.
Hold on,
How
hold
can
on.
I use up over there?
Because look, I'm showing you right now.
Oh, inside the square that we made.
Inside the square. Now, I can also have another rectangle down here that is similar. This could be a number 2. If you want a challenge, you can also add in right triangles. Here's the key though. If you're using right triangles, let's do purple. You want to make sure if this is 4, this side is 4. Okay, so another similar triangle to that would be 1 and 1. So I'm labeling the similar shapes with the same number. Okay? Triangles are optional, you don't have to do it. Okay? Question?
Can you do just squares if you wanted to?
Must use squares and rectangles.
Okay.
Okay? You must use those two. Triangles are optional.
Can you do like a weird shape but it's still has like equal something?
And they all have to be different shapes.
Okay, so question is, can I do a weird shape? So if you want to do,
Can you
say,
just do lines through the whole
like
thing?
a parallelogram like this, the hard thing is making sure that these are all the same length. If you're going to do something with polygons, they have to be what we call regular polygons. Grade 7, what's a regular polygon?
I don't know.
It's a regular polygon. It's like a circle.
How do I find a regular versus an irregular polygon? Last year?
Wasn't regular, all the sides are the same.
All the sides are equal. Okay, you can try it. It's going to be hard to fill up the whole square with those though. Okay, Hayden?
Okay.
Yep.
So we just have to do squares, right triangles,
Yeah, but the big thing here is that you have to show me which ones are similar, which means that you now have to look at the ratio between them. So this one, and this one all have the same ratio from width to height. Does that make sense?
No.
So here, these ones I would label like this. They have the same ratio. These ones, is this the same ratio as the square? It has a different ratio. So this one would be labeled something differently on your scene. Go ahead. Yep.
How many different kinds of ratios can you have?
Let's say you can have a maximum of 6 of each ratio. Okay? So you can have up to 6 different shapes that are all similar. So you might have to have one rectangle that's like this. You might have to have one rectangle that's really long and skinny.
Calculate ratio.
It's equivalent fractions, what we were just talking about.
But I don't know how to calculate.
I showed you over here earlier on. So you're just multiplying the top and the bottom by the same.
But how do I get the top and bottom?
Well, count how many squares you have. 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5. That's a 6 by 5. So Michaela here has a 6 by 5 rectangle. What's an equivalent rectangle to that?
5 by 6.
Yeah?
12 by 10.
A 10 by, or a 12
12 by 10.
by 10? Similar.
24 by
24, that's right. Yeah, it could be huge. You can
Does
even,
this have to be done before we leave?
no, because you've only got like a minute. Last question, then I'll stop the recording. Go ahead.
So when you have a square, if you multiply so the 12 and the 10, the 6 by the 5,
And then you
Yeah, squares are the easiest, right?
so it would be still the same. It would be number 1. Let's just say.
Squares are 1 to 1, so as long as they have equal sides, then you're good.
So all the
Somebody's
squares
knocking
would
on
be
your door.
Okay, guys, we're recording. Yeah?
all the squares would be the same.
Yeah, totally. But they, so one would be a 1 by 1. You'd have a 2 by 2, maybe a 4 by 4.
How does that make sense?
1 by 1, 2 squares by 2 squares.
But
You could have a 5 square.
multiply the 6 into a 12 and the 5 into a 10.
But what's your ratio of a square is 1 to 1. Because it's the same.
Yeah, so all of the squares would be in one group, right?
You can put them anywhere in the block though.
Yeah, I know. But they would still
Yeah,
be
they'd all have a number 1.
Okay.
All your squares would be number 1. Yep, Gabe.
Do we have to calculate the area?
No, not at all.
We just break the squares down? And then
Fill up the square.